to talk about convolutional neural network. What is convolutional neural network? Basically, the convolutional neural network is used for the image detection, object detection, and it is used in image captioning also. So what happened when we use the normal multi-layer network? It uses the one pixel for one input. That is, the image is made up of pixel by pixel matrix, 250 by 255 pixels. So in that case, the number of inputs will be 255 by 255 multiplied by 255. So this will increase the computation time. This will increase the number of bits. So our accuracy, our computation time will increase, and maybe we will face the problem of overfitting. So to avoid this, we convert the image into using convolutional network into a small input size. The major problem with multi-layer or ANN is that it is difficulty to input at its shifted version. Like we use CNN, we use the image of, we need to identify the image of a cat, and cat can be in the image at the center, maybe at the bottom, or maybe at the top of this image. So it is difficult for multi-layer perceptron to identify the cat at different location in the image. So this is another problem. Again, we lose the spatial information in the case of multi-layer perceptron. So we introduced convolutional neural network. The convolutional neural network first time used in 2012 in AlexaNet. AlexaNet network is used in ImageNet competition, and since then the CNN has a very good result for the image identification and object identification. So many convolutional layers are used in various type of competitions of ImageNet, like InvestNet, AlexaNet, and other GoogleNet. So you can check on the net how many layers are now in ImageNet competition of the last year. So what we are doing, we are reducing the size, we are without losing any information of the image, and that reduced size and reduced number of pixels are converted to a flattened vector. So if my image size is 3 by 3, it is converted into a flattened vector as this. So where we are using this ImageNet classification convolutional network? In image classification, object detection, and recognition of the faces. The problem with the image identification is that we have a higher number of pixels, and above it we have multiple channels. Like if we have, let me take this pointer option to show you. Let me have this 3 channel, that means 3 image is colored image. So blue, green, and red, these are the 3 channels. So we have the depth in the image, we have the width in the image, and height of the image. So number of calculation is around 8K in this. So we need to reduce this computation. That is why we are using the convolutional net. Okay, we use CNN model to train and test each input image through the use of kernels. What we are using? Kernels and filters. We also use the pooling to reduce the size of the image, and then passes the input to the fully connected network. And lastly, we apply the softmax function to classify the object. Like I have shown in this example, we classify particular portion, particular matrix has been taken, it is convoluted and converted into a small number of small matrix, number of rows and number of columns are reduced. Then again we pool. Pooling can be maximum, maybe the average pooling or some pooling, to reduce the size of our input. The size is again reduced. We used convolution again, and then Lastly, we use the fully connected and softmax matrix. So how to use convolution with the use of filters and the kernels. So what we are doing, we are using this filter, 3 by 3 filter. This particular value is multiplied by this. So you can see here 1 cross 1. This particular value 0 is multiplied with 1. So we have 1 cross 1 multiplied by 0. In the same manner, this multiplied by this. We are just stacking this filter onto the image. So, and multiplying the individual cell values and then summing up the values. In the same manner, if you can see 0 multiplied by 0, that means in image the value is 0 and here also the value is 0. So applying this filter and then aggregation, that is summation, we get the value 4. So instead of 9 by 9 matrix, a single value 4 is received to us. Then we shift this filter by 1 row and 1 column. So this is shifted by 1 row and 1 column. The next filter will be applied here. The next filter will be, it is shown in the next slide. You can see this filter is applied, and instead of 3 by 3 matrix, now we are getting only one value, and now our matrix size is being reduced by 5 by 5 to 3 by 3. Now we will move to how this computations has been, how the size is calculated for the output value. Here we can see that the width and the height and the width of the input image is HW, and the density depth we are not working. So, and the filter we have used is of size FH and FW, and that's with the same depth. We are not working on the depth, we are working only on the height and the width. Clear? Then the output value will be of H minus FH plus 1 by W minus FW plus 1. Depth we are not working, so depth is D, so it will remain as D. So take an example. There are various, we generally used multiple filters on a single image, maybe the horizontal filter, vertical filter, or maybe the edge detection filter, curve detection filter, or we want to see the blur image, we want to use the box, sharpen the image. So we apply various type of filter on a single image to identify the object. Now how this filter is applied? Suppose we are using 10 filters, then there will be 10 feature map. This is single feature map for a particular feature. So if we are using 10 filters, we will have the stack of 10 feature map. Clear to all of you? Each feature map is of size 32 by 32. We are using the filter of 5. Okay, and depth we are not changing. So output feature map size is 32 minus 5 plus 1. 32 minus 5 is 27 plus 1 is 28. So this size will be of 28 by 28 by 3. Since we are using 10 filters, so stack of 10 filters will be there. So you can see visually in this figure. We will move to the next slide. Like in this image, we want to identify the curve shape filter. So this is the curve identification filter. So what we are doing, we have 3 elements: input the image, feature detector and feature map. So feature detector is nothing but a filter we are using, and from this filter we are getting the feature map. Then we apply the non-linearity in this feature map using the ReLU function. The ReLU function will have the value between 0 to x. So what is x? X is this value. And if it is, what is the maximum value? 20 and 0. 20 is the maximum value, so non-linearity is introduced by value 20. But here the value is minus 15. So minus 15 is less than 0, so we keep 0 instead of minus 15. So the output can be seen here. The black lines after the value functions are missing. So this is by introducing the non-linearity. Another, we can reduce the size by use of the pooling function. What pooling function used to do? It reduces the spatial size of the representation, and it also reduces the amount of parameters. By default, then it will reduce the computation in the network. Okay, so it works on the individual feature map. Suppose this is the feature map. We use pooling for 2 by 2 matrix, and now we are using the max pooling. Max pooling, from this 2 by 2 matrix, only the single value 6 has been extracted, which has the maximum value. In this, the maximum value is 8, so max pooling will extract only 8. In the same manner, 3 and 4 are reduced. So from 4 by 4 to now the size of the image has been reduced to 2 by 2. In the max pooling, we take the maximum value. In average pooling, we take the average of all the values. And sum pooling, we take the sum of all values. So most popular matrix is max pooling. Now we will see the strides and padding used in convolutional layer. Stride means how much we want to move our filter or kernel in the input image. Suppose if we want to move the input filter by 1, then stride is 1. If we want to move the filter by 2, the size is more reduced. Input size will be more reduced, and we will move this by 2 filters, 2 columns and 2 row. So it reduces the feature map with the number of strides we are using. If number of strides are higher, then feature map, this output image has low number of height and width. So we need to decide based on this. And what is padding? Basically, in padding, what happens? We have picture with the 0 padding. We will have the number of row, first row and first column, last row and the last column will be filtered very less. Like in feature image, if we go into this here, this first column and first row, this last column and last row, use this filter only one time, whereas this image, this values uses the filter maximum time. So if the image concentration is at the row top or bottom or left or right, we need the feature map to be traced twice or thrice. For this purpose, we prefer to use padding. If we use padding, we need to introduce padding along with the edges of the images. So whenever the feature map is used, this corner size pixels are not ignored by feature map. Although it increases the size, but equal concentration is given on complete image, not on the center of the image. So if we, after this we flatten our input size. So we have used a convolutional layer with the use of strides and padding. We use the max pooling. In max pooling also we can use the strides and padding. So the flattening will, now the image is reduced. So image size has been reduced in height and width, not in the depth. So we can flatten it, like 3 by 3 matrix is flattened to 9 by 1 single vector. So, and this single vector is directly given as an input to ANN, like this. Okay, now the things are clear to you. This is fully connected network, which we have already covered in previous lectures. So what is the summary? We have W1 H1, that is width and height and depth. This convolutional neural network work only on the width and the height. Suppose the number of filter is K and the filter size is F and stride is S. S can be 1, 2 or 3 depending on the requirement. padding is always 1 or 0. So the width of output image will be the width of previous input image minus filter size. If padding is there, then p equal to 1. If it is not there, p equal to 0. Divide by strides. Stride is 1, then divide by 1, otherwise divide by 2 plus 1. So for example, if you have the image size 255 by 255 and the filter size 5 by 5, so what you are doing, 255 minus 5 is 250. Padding is there, so plus 2, 252. Divide by stride is 2, so you are dividing by 2. So 252 divided by 2 is what? 126. So resultant image will be 126 plus 1, that is 127. Here we are not working on the depth of the feature map. But suppose the number of feature map we have used is 5, then the stacked feature maps total output will be 128 by 128 by 5. So what we have done, we have taken the input image, then we apply the filters to get the feature map, then break up the linearity, we use the rectifier function, then we use the pooling step, which is providing our convolutional network with the faculty of spatial invariance. Now we are done with the pooling map. We have pooled feature map. Now we can flatten our pooled feature map. Now our flattened feature map is ready for the input in ANN. Okay. Throughout the entire process, the network building block like weights and feature maps are trained repeatedly in order to get the maximum predictions, near predictions and accurate prediction as possible. So thank you very much for the watching. We will be back with more videos in the next session. Thank you. If you have any doubts, subscribe my channel.